So in this video, I'm going to show you how to use some open source software to convert Esri shapefiles and load them into PostGIS. So I have my mod 5 data folder on my Z drive here. It's empty right now, and I have the mod 5 folder on the J drive. So I'm just going to pick up all these files, copy them, and then paste them over to this area, if it will let me. There, seems like it did it, and it's calm. So what we're going to do is we're going to load this shape file here, backpass shape, into PostGIS, but we also, part of a shapefile data set is the attributes, the index file, the projection file as well. So what I'm going to do is I'm going to go over this file in Notepad++. Okay. Now I've preloaded these links in the browser so that we can take a look, but you can go there yourself. So this is a little housekeeping. Is turn off echoing, clear off the screen, and then prompt you for your A00 number, lowercase a, and your password, first, last four numbers. You'll see this echoed on the screen. I can't turn it off right now. It will make the script overly complicated, but at least it's not embedded in the file, and it should work for everyone. Right. So OGR knows what the format is because we tell it's a backpass shapefile, so it can kind of guess by the extension. It can also snoop the first few bytes of the file to figure it out, but it actually has no idea where you want to go. So we have to tell it, right? So OGR to OGR, we have to tell it. By the way, I want to go to Postgres SQL, which in this world means PostGIS. If the layer is already there, so in our case that would be a table. Right, so if the table's already there, drop it, so that you can bring a new version of the table in. On specifically setting the projection, even though there's a projection file. It's found it doesn't run as clean when you don't set it. It almost needs to be ran twice in a row and then it's fine. But hopefully this will get it on the first run. So I'm sending it to the European Petroleum Survey Group, SRID 3005, which is BC Elbears, often as you know from me, best projection ever, because we call it MELP Elbears back in the day. So I'm going to go to Postgres, overwrite the table if it's there. The projection on the data is 3005. Now I need to put all my connection information in. Gamma.athena.bcit.ca. User, I'll substitute in your A00 file. It'll ask you to type it in on the screen. And then I'll use that exact same BCIT ID to set the database name. And then I'm also going to slide in your password. And then this is this NLN, this layer name. And so that means, and this is where we can go schema.backpass. I'm also saying the type is polygon. Okay, so what we'll do is we'll go to the GDAL page quickly and we will take a look at this. So I'm going to bring up the GDAL documentation. So the thing about GDAL is it's a much larger library. Geospatial Data Abstraction Library, and part of it is this ogr to ogr command line utility, which is what we're going to take advantage of. It can convert a ton of raster formats. I mean, the list just goes on and on. There's umpteen raster formats it can go back and forth from, which is really convenient, and umpteen vector formats. And specifically for us, that's an Esri shapefile. So somewhere in this big long list is an Esri shapefile, and Postgres. Right, so we can do a Control F and type in shape file. It'll be here somewhere, right? So it's there. I'm just going to back up, and we can find Postgres somewhere on this list. The list is pretty hefty in that. So part of the other options, or some of the options, if we go back to the script, is this layer name and this layer type. So I'll show you quickly where those are. So if we scroll down, we can see the layer name here. So assign an alternate layer name to the new layer. Otherwise, it's going to use backpass, right? But because I want to put it into a specific schema, I have to switch that. It would just go into public. I could fix that later. But so instead of taking the backpass shapefile that's on disk, right? it would probably just make a layer with that same name, but then it's going to put it in the public schema. So I'm going to rename it and put it into the GST7132 mod 5 schema, backpass. And then also the type. The type is, I'm going to tell it specifically to do polygon. Polygon or multi-polygon, if you're doing polygon data, are your go-tos, your safe sort of geometry types. But these specific names are based on an OpenGS Consortium standard, right? So instead of saying polyline, they say line string and things like that. So this is very specific to the OGC, and GDAL is just following the standard. And that sets the type. But if we go back to the script, there's also these little -LCO options too. But that's really part of the Postgres driver. It's called a layer creation option. And it's usually specifically for the driver. So if I go back here, I have that page open as well. The link is in the script. And not so much geometry type, but we're looking for geometry name. Set the name of the geometry column. So what it is it's going to go to the DBF file. It's going to find a bunch of columns in there, and it's going to build a table based on that. Then it's going to tack on one more column to that table. And here I'm going to set the column name to shape. That's what I do in the script. So here I have it, call it shape. So when I go look at that table, I got to look for a column called shape. That's where my geometry is going to be stored. With the shapefile dataset, it's actually in a different file, but we're putting this into a database, and so that different file is actually just going to be another column on the table, but the column we called shape. I'm also saying no to precision, and that's a layer creation option, and again, that's back in on this page. So in the DBase format, right, they use a lot of numerics, 10, 7, 10 digits, 7 for decimals, 5, 3, 5 digits, 3 for decimals. But that's all over the board, right? And in all honesty, from programming and using other software, ArcMap and ArcPro know what a float are and what a double are. And same with QGIS, it knows what a double is, because those products are typically written in C++, and so those programming languages, much like Java, much like Python, and C and C++, they know what doubles are, but these numerics, technically, they would be hard to find in a programming language. They're all over databases for some reason, but they're not so much in the programming languages. So if this data is going to be used by other software, if you can, put it in a format that you're pretty sure it will be able to handle, okay? And so I know doubles are pretty safe, so I'm going to say no to precision. Don't try to match exactly what's in the DBase format. If you encounter a number that has decimals, slide it into a float. Okay, that's what I want to happen. I still might have problems with big ints, so I might have to scale those back so that it will work with QGIS, no problem, but I would have to scale it back for it to work with ArcPro and ArcMap. So I still might have to fix the data up a little bit later on. Okay, but that's what those options are. So the LCO options are specific to the Postgres driver, and the -NLN and -LNLT are sort of generic OGR options. There are a ton of options on this command, and right, you wouldn't be a pro at this command, after a couple of years of doing different types of data. But we're going to run this script, and this should load the data for us. If we get an error, it's probably with our password, but I have noticed that sometimes on the first run of a freshly created schema, it gets really confused about the spatial reference system table in the public schema, but on the next immediate run, it's okay with it. So if it does crash for you, just use the up arrow a couple of times to rerun the batch file and see if that fixes it. Otherwise, it's probably a password setting, or you haven't created the schema yet. So as I noted here, the schema has to be created for this to get loaded. It has to exist before. But I just wanted to go over this file. So what we'll do now is we'll go into pgadmin and actually create the schema. So I just closed the file. I'm just going to go back. I'm going to start up pgadmin4. So again, I'm on the war desktop. And I'll fire up pgadmin4, and it'll take a couple seconds to load. So it's loading on the screen. I'll put my master password in. Now I have a couple of connections here. I have one to Gamma and I have one to my Gamma for shooting video, which has a lot less accounts in it. It's a little bit cleaner. It just has the one test account and a clean sort of schema setup. So I'm going to right click on here and go create schema. And this is where I said this schema has to exist. So GIST 7132 M05. And I'll go save. There we go. So now what I have to do is I have to open up the OSGeo for Windows shell. So again, we're on the War desktop. And I'm going to go to Open Source Geo shell. And it's opened up on the C drive. Now the immediate thing I have to do is I have to switch to the Z. So you go Z colon and then enter. I'm going to change directory to var GIST 7132 M05 data folder. I'm going to do a dir just to make sure I'm in the right spot. I can see the shaped postgis.batch file. So it's going to run ogr to ogr. Okay. We're in a special shell. If you look at the top, it says Open Source Geo 4 shell. Right? It's got this o-help. Tell you all the open source commands that it has access to. Right? So the one we're going to be using is ogr to ogr, but we're going to do it by running the batch file. So I'm going to go shp.bat there. I just enter my student ID. This will be your student ID with a lowercase a. And then your password. Now, this is Unix, so no news is good news. That'll clear the screen. So what I'm going to do now is I'm going to go back and see, did the data actually get in or did it lie to me? So I'm going to open up tables, and backpass is there now. I'll right click and go view data, all rows. And we'll just try to scroll across till the end. And there is the shape column that we defined in the script that we wanted the geometry column to be called shape. So I'm going to look at the geometry viewer real quick. And so this will give me a spatial view, if you click on the little eye icon, of the data set. Now where that bar is, was there, I can zoom in on it. And I can actually do like a quick identify, and it'll actually pop a value if I want to inspect the polygons. But basically, if I can see the data like that, it got in. So that's good. And that I can also go check my public schema. So not the mod 5 schema, but not topology either, but the one called public, if I could click proper today. And in there, you're going to find views, and one of them is geography columns, and I'm going to go view the data in that one. Now, right now, probably just have one entry because this is the first spatial data set you've loaded. But basically, it'll say what database, what schema. So database, schema, name of the layer, name of the geometry column, the fact that it's two-dimensional, and the fact that it's EPSG, European Petroleum Survey Group, 3005 SRID, which would be BC L-bears or MELP L-bears, and that the type we loaded was polygon data. So it looks like it got in. It did get in without errors in that. And if you have a problem, the first approach would be to rerun the script again right away, and make sure you're typing your A is a lowercase a, and that you're typing in the right password, first, last four numbers. But for now, this concludes this video.